Good morning, my awesome students. Today is a February 20th, so don't forget to date it. So I'm just gonna put it somewhere over here. 2/20/24. Finally, we get to talk about graphing quadratic functions, which the standard form of that is x squared plus bx plus c, which we have to put it equal to y or equal to f of x or function of x. Okay, before we get to this one, I have to tell you that this one is foldable kind of note. So you need to cut this part and this part. And then you need to cut this part and this part. And also you need to cut the whole bottom line from here to all the way down here. Okay? Then we can, after we're done, I can show you how we fold it and we glue it to our notebook. Okay. We can do that after we're done with our notes. Okay. Let's talk about graphing quadratic functions. First of all, you can see that this is not a straight line anymore, so we don't have linear. We have a parabola, okay? So this graph's called parabola. And how we define that is that the definition of a parabola is the U-shaped curve. So let's just write it down. U. Okay, which is a graph of a quadratic function. Okay, as you can see, this graph looks like a U and it goes all the way up, so it doesn't stop somewhere for this case. It has a minimum, or if it's gonna look like this type of, like a upside down U, it will have the maximum point. This one has a minimum point. It has x-intercept where it crosses the x-axis. It has y-intercept where it crosses y-axis. We're going to talk about all of this for the whole week, okay? So I'm going to put all of this information in one foldable note, and then we're going to go over the detail more. Okay. The set of all inputs which inputs are x values. For this graph, if you take a look at it, for this graph, all the x values goes, like if you take a look at it, it goes up and this part goes up. So if you stretch it and just imagine how far this graph can go up, it will cover all the x's. So for this graph, our inputs would be all the x values, or we can just say it starts from negative infinity to positive infinity, or just the infinity. Or we can say It's all real numbers. Or a capital R, which is representing all real numbers. Okay? Now, if we talk about x values, now we have to talk about outputs, which is our y values. So the set of all possible outputs or, of course, y values. For this graph, if you take a look at it, vertically, this graph starts from here and goes all the way up. So it starts from -8, all of our y starts from -8 and goes all the way up to who just knows where. So it will be all the y's greater than equal to -8. Now, the other attribute that we have for this graph is the vertex. What is the vertex? It's the minimum or maximum point of a graph. If you take a look at the mountain, you see the top of the mountain, and that would be the maximum part of that mountain. If you take a look at the, I don't know, like some graph like this, for example. If you take a look at the depth of this, the lowest part of this graph, you find the minimum point of that graph or maximum point of something. Those are actually represent the vertex of that thing or that graph. Like maximum point of the mountain is the top of the mountain, and that's the vertex, okay? Maximum or minimum represent the vertex of a graph. So I'm just going to say the maximum or the high point or the minimum or the low part on the parabola. What was parabola? The U-shaped curve graph called parabola. So for this graph, the vertex of this is minimum part of it, okay? It's this point. And the point, the point is -2 and -8. The x-coordinate is -2. The y-coordinate is -8. So I'm just going to put -2 and -8. That's the vertex. So I'm just going to point it at, just draw a line so you would see. So this one is this point. Okay. Now, let's talk about the axis of symmetry. We're going to talk about all of this in more depth for the whole week, but I just want you to have this note for when we have to go over it, you can just refer to it, okay? So, imaginary vertical line that cuts the parabola in half. Oops. So what is that imaginary line actually? So you can see this is a U shape, right? So the axis of symmetry is this line that cut through this graph. So if you fold this, it will lie on top of each other. So that means this part is the same exact as that part. It just cut it through and cuts it in half. So this line is the axis of symmetry. And the point for that axis of symmetry is x equals -2 because it's a vertical line passes through x equals -2. And that point is your axis of symmetry. So the equation for it is x equals -2, which is the x value of the vertex. This is your vertex, and that's your x value. You can just take a look at it that way. So basically, you can say, whenever I found my vertex point, which is minimum or maximum, in this case, we have a minimum, and the coordinate for it is -2 and -8, the x point is your axis of symmetry always. Or you can say there's a formula for it, but I'm not gonna really talk about it. I'm just gonna add it over here. You can just write it down, and then we can talk about it this week. -b/2a. That's the formula for it. If we have the actual equation like this, okay, then we can find it that way. But we're just not going to talk about it right now. I just want you to have it in your note, and then we're going to go over it later. Okay? Now, the point where the graphed parabola crosses the x-axis is what? We call that roots, zeros, or x-intercept, or solution. So if you take a look at the back, you can see it says roots, zeros, but I want you to add another names to it because they call them a lot of names. So they can call them roots, they can call them zeros, but there are other names for it too, which is x-intercept or solutions. Okay, add that to it too. Okay, so for this case, the x-intercept, if you take a look at your graph, the x-intercept is the part that this graph passes through your x-axis. So it crosses through this x-axis. That's why we call it x-intercept. So if you take a look, you see these 2 points crosses the x-axis.